This video is an introduction to the normal curve. Now, we've talked about the normal curve before. Previously, we've thought of it as what we've called symmetrical data, or another word or name for it is bell-shaped data. Now, bell-shaped data, you might remember, means that all of the data, for the most part, is grouped in the middle. And then the rest of the data kind of tapers off small amounts to both sides. You might also remember that for that reason, since the data is grouped in the middle, the mean is in the middle. And this also gives us an opportunity to represent standard deviation. Standard deviation, you might remember, is the spread of the data, how spread out the data is. So we typically can draw 3 standard deviations away from the mean. So this would represent one standard deviation, and then another standard deviation, and then another. And standard deviation goes either side of the mean. So all of those represent a standard deviation away from the mean. Now, there are some properties of the bell-shaped curve that are useful. First, since the mean is in the middle, that also, because of the way the data works, implies that the median is in the middle, and so is the mode. All 3 of them end up being equal and in the middle. Now, when I say equal, of course, that doesn't mean exact, but very close. Second, as I already mentioned, it's symmetrical. But in particular, it's symmetrical around the mean. So half of the data then is on one side of the mean, and the other half of the data is on the other side of the mean. 3, it represents probability. Now we're going to get more into this in a later video, but it will eventually start to mean to us a way of talking about the probability of something occurring. Fourth, we can apply or use something called the empirical rule. Now this one is a significant rule. The empirical rule says that if you go one standard deviation away from the mean, that this will represent about 68% of all the data. If you were to go another standard deviation away, so 2 standard deviations away, this is going to represent 95% of all of the data. So 95% of all of the data is within 2 standard deviations of the mean. And if you were to go 3 standard deviations away, that's going to represent 99.7% of all of the data. So 68% of the data is within 1 standard deviation. And then 95% is within 2 standard deviations. And then 99.7% is within 3 standard deviations.